Okay, so this is sample problem number 2. This is just a continuation from our sample problem number 1. And the problem wants us to somewhat solve for the maximum allowable force that can be applied if we have these three limits. The shear stress is 40 megapascals, the bearing stress is 90 megapascals, and for the tensile stress is equivalent to 120 megapascals. So means to say that the problem wants us to solve what would be the corresponding applied loads if we have these three limits. Okay, we have these limiting factors. So same free body diagrams as we have in our last problem. We have this one. Two metal plates stacked to each other with three rivets, and then simply solve for what is P for this problem. So let's try to solve. Let's try to solve for. We're going to use the shear stress, okay, for tau. The formula for the shear stress is again tau is equals to the applied shear load divided by the cross-sectional area of influence. But the problem, as we had in our first sample problem, we have three rivets. Means to say that this should be V is equals to 3A. Okay, and what we are going to solve here is simply what is V for shear stress. So that's the simple algebra. V is equals to 3A multiplied by the shear stress. So substitute V is equals to 3. What is A? That should be the area of the rivet. Okay. Should be pi. And the diameter is from the problem itself, go back 20 millimeters. So that should be 0.02. Yes, that should be 0.02. So diameter is 0.02 meters squared divided by 4, then multiplied by 40 megapascals. So 40 megapascals. And then solving for V, let's try to write it here. So V is equivalent to approximately 37,000, okay, 699.11 newtons. Okay. So this should be the corresponding applied load, or rather the shear load, if we have a limiting factor of 40 megapascals for the shear stress. Next would be for the bearing. Okay. Applied bearing load. So sigma sub B is basically P sub B over 3 TD, because we have three rivets. That's why we have a denominator of 3 over here. Solving for P sub B, just simple. 3 TD multiplied by sigma sub B. Okay. So P sub B is equals to 3. What is the thickness of the plate? The thickness is 25 millimeters converted into meters. That should be 0.025 meters multiplied by the diameter of the rivet. That should be 0.02 meters. And then sigma sub B is equivalent to 90 megapascals. So 90 megapascals. P sub B is equivalent to approximately 135,000 newtons. Okay, 135,000 newtons. So this would be the corresponding bearing load if we have a limiting allowable stress for bearing equivalent to 90 megapascals. And last but not least, we just need to solve for the tensile stress. So by doing that, just need to remove this one. Okay, for that we have some excess space to solve. So sigma sub t is equals to P sub t divided by A sub t. And don't forget again, this is the isometric view of the metal plate. I like this one, like that. We have the rivets here. We have three rivets. And the area of influence should be this one. Or if you want, you can use it here. this portion, which as long as it is perpendicular to the force applied. So which to say that this is P sub T. This is the cross-sectional area. Or you can use the area inside because we are dealing internal forces and we have 3 rivets. And since again it is said by the problem that the force is evenly distributed throughout the 3 rivets, means to say that we just need to subtract the length of this plate to the diameter of the rivet. Okay, by doing that, should be like this. Solving for P sub T. Okay, P sub T is equals to what is this? Sigma sub T is 120 megapascals. 120 megapascals. And A sub T should be the thickness. Okay, the thickness of the metal plate. That should be 0.025. And then subtract the length of the metal plate. That should be 130 millimeters. Okay, because this is 130 millimeters. 130 millimeters. So 0.13 minus the diameter of the rivet, 0.02. Okay, and solving for P sub T, and don't forget, as much as possible, we need to simplify it to the nearest answer. So since this is the solution working formula that we have, so simplifying that one should be 330. Okay. 330,000 newtons. So, again, for problem number 2, these are the corresponding loads if we have these 3 given stresses for shear stress, bearing stress, and the tensile stress. So for shear stress, that should be 37,699.11 newtons. For bearing stress is 135,000 newtons, and for the tensile stress is 330,000 newtons. So that's the answer for problem number 2.